In this part of vector, we are going to discuss the column vector. And column vector is very important in vectors. Once you understand the column vector, we are going to use it for the whole of the lesson, or the whole of vectors, even vector 2 in form 3. So what is column vector? Column vector represents the displacement of a vector. We said a vector is a displacement. I'm going to use a Cartesian plane to demonstrate that. So let me draw a Cartesian plane here. So we have the Cartesian plane, we have the y-axis, and we have the x-axis here. So we show the arrow there, and then we have our x here, and we have our y there. Now, when you draw the Cartesian plane, you must label. So we have 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are going to use a Cartesian plane to demonstrate what is a column vector. We are going to take 2 points, and these 2 points on the Cartesian plane, we will take A, which is 2, 1. So you read 2 and 1. That is where we have our A. It is coordinates 2, 1. And when we have B, which is 4, 7, so we take 4 and 7. That is where we have our B, 4 and 7. You join the 2 points to come up with a vector. And when you have a vector, we said you must always indicate the direction. A vector has a direction and magnitude. So we want to get the column vector AB. What is our column vector AB? What is going to help us are the components. What are the components? You can see in A, x has changed from 2 to 4. So you can say, if we draw a component here, that to mean A has changed from 2 to 4. So how many units do we have here? We have 2. Then if you look at the y, it has moved from 1 all the way to 7. So if we draw a component there, then we have this is 7. So we can say, in terms of displacement, then the vector AB is equals to, it has changed. The x component has changed to two components, and no, here it is, here let's correct this. We have here it is 7. It is 6, not 7. So 1, 2, 3, 4, 5, 6. So here we have 6 units, and therefore we say this is 6. So column vector describes the displacement our vector has, that is displacement from A to B. And how do we get that? We get AB, we get the x change in x, which is 4 minus 2, and change in y, it is 7 minus 1. And that is how you are getting 2 and 6. So that is how we get the column vector. Now, if the displacement you see the displacement here is to the right. So, actually we can put to the right. So when it is to the right, then we say it is positive. That is to the right. That is x displacement. When it is to the left, then it is negative. That is to the left. To the left. I'm going to show you how that happens. Y displacement. in this case it is upward. So when it is positive upward, and negative downwards. So that is how we describe the displacement. Let me use another example to demonstrate this negative and positive displacement. So what we do, we can still use the same diagram. We just make a duplicate of it, and we make two other points. Now let's say we have 2 points. Here it is P, and here it is Q. So we can get the coordinates of P and Q. P is at 2, 9. So P is at 2, 9. What about Q? Q is at 8, 2. So Q is at 8, 2. Now, when we get PQ, we join the 2 points to come up with a vector, and this is the direction of the vector. So what here we mean is that PQ is equals to, we draw the components. Let's draw the components here. That's the component, and this is the component of y. So that is the direction of our component. We can get the units here. So for x, it is 1, 2, 3, 4, 5, 6. So it is 6, which is the same as 8 for in Q minus 2. And then we take 2 minus 9. So you see here we get what? We get 6. 8 minus 2 is 6. 2 minus 9 is minus 7. So you can see now the displacement of y is to the negative direction. That is why we have negative 7. We can take another vector, which is we can say, let's take 2 points. Let's take that point to be our M, and we take this point to be our N. So this vector, we can join it and get the vector Mn. That is the direction. The coordinates of M are, we have said, it is 10 and 8, and N, it is 5 and 7. So we say Mn. Mn is equals to, now we take, x has changed from 10 to 5, so we say it is 5 minus 10, and the other one has changed from 8 to 7, so we say 8 minus 7. So this gives you what? 5 minus 10 is minus 5, and this is 1. So here we have, this is negative, that is a negative displacement of x. Of x axis. Now the other one, this one is negative of in y-axis, So that is why I said when we have displacement downward for in y, then the displacement is negative. Here we have, actually here we have not indicated the displacement. We can indicate this as our displacement. That is our displacement. So you see now here it is x is to the negative, but y is upward. It is changing to the upward. So that is what the column vectors are. Having learned that, we have meaning that if you are given, it is not a must that when you are expressing the column vector, you always draw the Cartesian plane. Let's see, if you are given 2 points, for example, you are told AB, you are told A, the coordinates of A are 3, 5. The coordinates of B are 6, 7. So you can get the vector AB is equals to, you take 6 minus 3, 6 minus 3, and you take 7 minus 5, 7 minus 5. That will give you what? 3, 2. So that is this is what we call column vector. Vector. Think here we left letter N. Here we left letter N. So here we have column vector. So that is a column vector. I think column. Let's put that. So that's okay. So we now have the column vector. So that's how you get the column vector. If you are given P is 5, 2, Q is Q, you say it is you say you can even use a negative -4, and 9. So you can get PQ is equals to, you get -4 minus 5, and you get 9 minus 2. So that gives you what? -9 and 7. So getting a column vector, you use a coordinate. What is important to note is that column vector represent displacement. From there, let's do an example. So we have an example. So you are told find the sum of each of the following. Column vector. So you have column vectors, and illustrate their solutions graphically, and illustrate their solutions graphically. Now you understand what is a column vector. We are told that A, we have A is vector A. We can use that to indicate the vector. It is 2, 3. So that's a column vector. B, and we say, and B is equals to 7, 1. So those are column vector. We have part B. We have, you can use that to indicate it's a vector. We have C is equals to -4 and 2. We have D is equal, and D is equals to D is equals to 5 minus 2. Now, so when you are adding this, so here we can say A plus B and C plus D. How do we do that? What we do is that we say that since A plus B, let's delete this. I don't need that. So the sum of these two vectors, A plus B rather, not D, B is equals to 2, 3, you add to 7, 1. Okay, so you add the corresponding components. 2 plus 7 will give you 9, and 3 plus 1 is 4. We can illustrate this graphically and say, since okay, let's draw the Cartesian plane. Let's have a Cartesian plane here. So this is our Cartesian plane. We have our x is 9, so, and y, the highest value. Okay, let's go that. So we label our Cartesian axis. We say it is y, it is x. So this is 0. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. We have minus 1, minus 2, minus 3, minus 4, minus 5. Now, if we go back, we have said that let's have this. So this is what we have. I want to put it here. So we have that is what we have done in the previous page. So we have said A and B. So A, we can demonstrate A using we have 2 and 3. So the displacement we can draw. Let's use a different color. So we can say along the x-axis we have 2 units. Along the y-axis 3 units. So that is our vector A. So that is our A. Then we have B. B is we have 7 units. 1, 2, 3, 4, 5. Let's remove this. So we have 7 units. 1. We have 1, 2, 3, 4, 5, 6, 7. How many units? 1 along the y-axis. So that is our vector B. So this is our vector B like that. So when you add the two of them, then you have, this is A plus B. That is a combination of vector A plus B. And as you can see, we are talking of 9, 9, 9, 4. You can count along the x-axis 1, 2, 3, 4, 5, 6, 7, 8, 9. Along the y-axis 1, 2, 3, 4. So that indicates the sum of the two vectors. We go back and see the other one. The other one we are told we add C plus D. So C plus D is equals to minus 4, 2, and plus 5 minus 2. So that will give us what? Minus 4 plus 5. That will give us 1. 2 plus minus, that is 2 plus minus 2. That gives us 0. That will give us 0. So we can demonstrate that on the Cartesian plane which we have. We can use this. We can say, let's put that on our page here. This is what I'm going to do. then I move to my page, and then I bring that to here. So that is that. Now we can be able to, we can pick that point at, so we say our C, we can use we can even use this side here, it doesn't matter. So we have -4, so we can take x is to the minus direction. So we say that we have said that x is -4, so we take 4, we move to the left, 1 2 3 4, so and 2 to the 1 2, so that is our vector C. So this is our vector C. We can put it so this is our point C. Then we take our D. Y is in the negative, so we say positive, 1 2 3 4 5. How many units to negative? So we move downward, 1 2. So that is our vector D. So this is our vector D. So meaning that we can, this vector A plus D is that vector. So that is what will give us A plus D. A, that is A plus D. And A plus D we have said it is 1 0. So as you can see, it is 1 unit displacement in the positive direction of x, but 0 displacement. It is horizontal. It is parallel to the x-axis, so y-axis. So it does not have any y displacement, and that's how you get that. I hope that one is clear. Finally, we have we can take another example. Let me give you another example. So we have example 2. Example 2. Now example 2, we are told if A is equals to 3 2 and B is equals to 1 4, then find 3A plus B plus 2B. In this example, we have not been told to illustrate using the Cartesian plane. So you just say solution to this is now we have 3 A is equals to 3. We insert our A, it is this one, 3 2. So we open the bracket. So 3 times 3 is 9, 3 times 2 is 6. Again, we have our 2B is equals to 2. Our B is 1 and 4. We open the bracket, and 2 times 1 is 2, 2 times 4 is 8. This means that if we add the 2, then 3A, plus 2B will be, our 3A is 9 6 plus 2 8, our 2B, this gives you what? 11. That gives you 11 and 14. So that is a vector. That is the sum of the two vectors, and you get that as a solution to that. So I hope now you understand what is a column vector, and it is very important. I have said it is very important. Column vector, as we are going to deal with in 2 dimension and in 3 dimension. So if you have any question, you can always put it in the comments. I will be able to respond. Now I want to give you a question which you can try and see whether you'll be able to do that. So practice question. So you are told practice question. So you are told if A is equals to 3, 1, comma B is equals to minus 2, 7, C is equals to 6, 5, and D is equals to 0 minus 5, find. You are told to find A, Roman number 1. You say 3 plus 2B, 3 plus, 3A plus 2B. Very similar to what we have done in our example. Roman number 2, you'll be able to find 5B minus 3A. Then we have Roman number 3. You get a half C minus 3 over 2D. And we have Roman number 4. You get a third A plus a third B plus a third C. Then we have part B of the question. You have find the scalars. Find the scalars R and S such that R, A is a vector, plus S C is equals to 9B. So you can practice on that, and you find the solutions. Let me provide solutions for you in case you work it out. So we have A, Roman number 1. You should get 517. Roman number 2. So these are answers. Roman number 2, you get 21 and minus 16. Roman number 3, you get 3 and minus 5 over 6. We have Roman number 4, you should get 7 over 3 and 13 over 3. So that is, and then the other one, S is equals to 23, and R, that is B, R is equals to minus 52. Those are the scalars. So I hope you'll be able to do that. Practice on that. If you have any comment, put it in the comment section. I will be able to respond. And that brings us to the column vector. So you can let me know if you can click down there, you get a link to the next subtopic in vectors. If you have any question, or you have a topic you would like us to cover, you can always get me on 072 535 7594 or 0.36 that is 545363. You can get me on that, or you can comment there. You can also join my online math class, classes that I offer, and don't forget to subscribe, like this video, and also you can share with your friends. This will help me to build a strong YouTube channel, which will be able to give more revisions on maths and other subjects. Thank you for watching.